Operations with radicals. A radical is a number expressed with a root. Whenever you're working with radicals, I'd like you to always remember your perfect squares. 1, 4, 9, 16, 25, 36. Square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, etc. Let's look at an example. I'd like to express root 12 as a mixed radical. I start off by saying I need two numbers that will multiply together to give me 12, one of which is a perfect square. I can write root 12 as the root of 4 times the root of 3. And then I can take the square root of 4 as 2. Let's look at 147. So the square root of 147. I can rewrite 147 as the square root of 49 times the square root of 3. I can take the square root of 49 in my head. That's 7 root 3. Let's look at an expand and simplify problem. I'd like to expand 2 root 3 times 7 root 2. I'm going to multiply the leading coefficients together and then the radicals together. So I'm going to have 14 root 6. I always take the opportunity to look at my final answer to see if I can take a perfect square out of it. In this case, I cannot take the square root of 6 in my head, and there are no two numbers that multiply together to give me a 6, one of which is a perfect square. So that's as far as I can go with that problem. Let's look at this one. 3 root 15 times negative 2 root 3. Again, I'm going to multiply the leading coefficients, and I'm going to multiply the items under the roots. So 3 times negative 2 is negative 6, and root 15 times root 3 is root 45. I want to look at the root 45 and see if there is a perfect square product I can take out of that. I can think of root 45 as the root of 9 times the root of 5. And then the square root of 9 is 3. And negative 6 times 3 is negative 18. So the product of these two mixed radicals is 18, negative 18 root 5. Let's do an addition and subtraction. I've got 4 root 18 plus 3 root 50 plus root 200. None of them appear to be a common root, have a common part that I can work with. But let's start off by writing them as the product of numbers that have a perfect square in them. So that's the same as 4. 18 can be written as root 9 times root 2. Root 50 can be thought of as root 25 root 2. And root 200 can be thought of as root 100 times the root of 2. I've now got root 2 as a common radical. Now I'm just going to take these perfect squares and multiply them by the leading coefficient. So the square root of 9 is 3, 3 times 4 is 12. Square root of 25 is 5, 5 times 3 is 15. And the square root of 100 is 10. Now I'll just add together my leading coefficients. 12 plus 15 plus 10 is 37. Yes, 37. Okay. Let's look at multiplying two binomials. I have root 3 plus 2 root 2 times 5 plus 5 root 2. I'm just going to FOIL it. Every term touches every term once. So now I'll just multiply the terms. Root 3 times 5 is 5 root 3. Root 3 times 5 root 2 is 5 root 6. 2 root 2 times 5 is 10 root 2. And then 2 root 2 times 5 root 2 is 10. And then the 2 root 2 times 2 root 2 is just 2. That becomes 5 root 3 plus 5 root 6 plus 10 root 2 plus 20. I can't take any of those any farther, so that is my final answer in this situation. Let's look at this situation. I have a 4 plus root 5 times a 4 minus root 5. If I look at that, I should recall that that looks like a difference of squares. If you recall from your binomial work, if you have a plus b times a minus b, when you multiply them together you get a squared minus b squared. So this is like my a term, and this is like my b term, and there's just a plus and a minus difference. So I'm just going to square the first term, and I'm going to square the last term, and I'll put a minus between them. And 16 minus 5 is 11. Finally, let's look at an example with a fraction in it. I have 2 root 20 plus 3/4 root 80 minus root 125. As always, I'm going to look at each radical and see if I can write it as the product of a perfect square and another number. So the first one is going to be 2. The biggest perfect square I can take out of 20 is 4. Square root of 4 is 2. So 2 times 2 and then root 5. Root 80 can be thought of as root 16 times root 5. And root 125 can be thought of as root 25 root 5. So now I've got 4 root 5 plus 3 over 4 times 4 root 5 minus 5 root 5. Now if you look at that fraction, I've got 3/4 times 4. The 4's cancel out. I'm left with 4 root 5 plus 3 root 5 minus 5 root 5. Now I'll just add my leading coefficients. 4 plus 3 is 7, minus 5 is 2. And that's how you work with a fraction with radicals. Thank you for watching this video.